All right, humans, please remember that problem number 7 on the test. Okay, I called it number 7 on the practice test, but remember, it's a bonus question. Bonus question. Okay, it's supposed to be extra credit, so don't get all sassy with me when it shows up on your test. So, we begin by drawing a free body diagram of the box. Notice it's on a rough surface. Whenever you read the word rough surface in physics, that means friction. Don't forget that. So we have a normal force. Awesome. We have the weight, which is the same as the force of gravity. That's going to equal m times g. I'm just going to write that there. I don't know if I'm going to use that formula. I don't, but I'm going to draw it. We have the pushing force. I'll call that Fp for pushing because you're pushing the box. And then you've got a friction force going to the left. So exciting. Now we want the acceleration of the box. If the force of friction is 2 Newton, that's going to be pushing force minus the friction force. They have a tug of war. Always subtract off your friction force in these problems. Since it's not balanced, that means it's equal to ma. And now we can put in our numbers. 10 newtons minus 2. Whoa, gross. 10 minus 2 equals 2 times the acceleration, a. And when we actually get that, we're going to get a is 4 meters per second squared. Now, the force of friction necessary to keep the box moving at a constant velocity, we've got the pushing force. It fights the friction force, and the effect is that everything balances. So we have 10 minus friction equals 0. So to keep the box moving at constant velocity, we need a friction force of 10 newtons. And that is it for this practice test.